So welcome to the next unit in IB Chemistry, strong and weak acids and bases. So we've looked pretty much at strong acids and bases. We're now going to focus more on the weak acids and bases and what it actually means to be a strong or weak acid or base. So essentially what we're going to learn about in this topic, or this unit of this topic, is what strong and weak acids and bases are and why they're called strong and weak acids or bases. Strong acids and bases around their conductivity, what a strong acid is, and how it relates to its associated conjugate base, and a strong base is a good proton acceptor and a weak conjugate acid. Okay, so by the end of the unit you should be able to distinguish between strong and weak acids and bases in terms of their reactions with a various number of compounds, and also relate it down to their electrical conductivity. So basically, in a nutshell, a strong acid or base is one that completely dissociates in water. Now, what do we mean by that? Well, it means that basically it goes from being the compound into the associated ions, and aqueous ions in solution. Okay, so the example there given is hydrochloric acid, where it's going to be completely dissociated into protons and chloride ions. Okay, so pretty much all the hydrochloric acid molecules disappear and are turned into the protons and chlorides. Okay, so 99.99% of the species in solution are protons and chloride ions. So looking at strong acids and bases, strong acids completely dissociate or break up, split up into ions in aqueous solutions in water. So for example, a monoprotic acid like nitric acid completely dissociates to form H+ ions and nitrate ions in aqueous solution. And diprotic acids like sulfuric acid obviously form two protons instead of one because they're diprotic, and also form a sulfate counterion, which is also in an aqueous solution. Also, strong bases completely dissociate, just like strong acids, into ions in aqueous solution. For example, sodium hydroxide makes sodium ions and hydroxide ions. Note the arrow indicates the complete dissociation, so it's going completely into the associated ions in solution. Moving along to weak acids and weak bases, weak acids only partially dissociate into ions in aqueous solution. So not all of the molecule turns into the associated ions in solution. That's why it's an equilibrium. It could also be written as HA plus water, giving A- and hydronium ions. Okay, so we replace the long carbon chain here with an A instead. Okay, just saves time writing. Or HA aqueous forms A- and a H+. Okay, so this all basically represents the A part of the molecule. Right, so weak bases also partially dissociate into ions in aqueous solution. So for example, ammonia plus water partially dissociates to form ammonium and hydroxide. Okay, but only partially, not completely like strong acids and bases. So note the arrow indicates only partial dissociation. So in order to determine weak or strong acids and bases experimentally, basically a weak acid has a higher pH than a strong acid of equal concentration. So 1 molar, say, hydrochloric acid has a pH of around 0, whereas 1 molar acetic acid or ethanoic acid, as we should call it, has a pH around 3 or 4. A weak acid does not conduct electricity as strong as a strong acid, essentially because it's not forming as many ions. Okay, so ions are the charge carriers in solution, and a weak acid reacts more slowly than a strong acid. For example, with an acid in a metal to form hydrogen. Okay, so you put a metal into a solution of 1 molar hydrochloric acid, it's going to fizz, create lots of hydrogen. Which you put into 1 molar ethanoic acid, it'll take more time to form bubbles. So examples to be learned in terms of weak and strong acids and bases. So for strong acids, looking at hydrochloric acid, nitric acid, and sulfuric acid, okay, the three mineral acids. For weak acids, the carboxylic acids from organic chemistry. So for example, ethanoic acid, which you more commonly would know as vinegar, and carbonic acid. And strong bases are group 1 hydroxides like sodium hydroxide or barium hydroxide, whereas weak bases would be bases like ammonia and the amines, which are also get important when you're looking at biology and amino acids. So looking at, in summary, whether a compound is a weak or strong acid or base, here are a series of compounds. I wish you to pause the video now and work out whether they are indeed strong acids or strong bases, or weak acids or weak bases. Okay, so ammonia, hydrochloric acid, potassium hydroxide, and ethanoic acid. Okay, so ammonia, it's a proton acceptor, so it's a base and it's a weak base. Hydrochloric acid is a very strong acid. Hydroxide, potassium, so it's going to be a strong base. And ethanoic acid is going to be a weak acid. And that is pretty much all you need to know about strong and weak acids and bases.